Then I will start with my presentation. Is it okay? Can you see me, hear me?
Yes, thank you, thank you.
Okay.
It works.
Okay, then first I want to thank for this invitation to present the Quiet project. And originally my colleague Dragan Simic would present this, but we changed. And now I want to speak about the Quiet project. The Quiet project, I give short overview. I will talk a little bit general information about the project and the consortium partners, the motivation, project goals, the baseline car, and also then the achieved results. The Quiet project, the acronym stands for Qualifying and Implementing a User-Centric Design and Efficient Electric Vehicle, is aimed to give a good contribution to improve the range for electric cars. The topic was the electric vehicle user-centric design for optimized energy efficiency in order to increase the range for electric cars. And the project coordination is by Dragan Simic, and the project total costs and the total contribution is about 7 million euros. We have here a very good and balanced consortium working on the Quiet project. This is mainly the AID is the coordinator. This is also my company where I came from, and also Mr. Simic. The AID is Austria's largest research and technology organization. The shareholders are the Republic of Austria with about more than 50%, while the Federation of Austrian Industry takes the rest. And we are located in Vienna, in Graz, Wiener Neustadt. The other partners, we have also the OEM Honda. He is providing also the vehicle demonstrator car. We have AVL and also the subsidiary in Germany, Q. Deutschland. They are responsible for the HVAC system. Ventrex are providing the expansion valve technology. University of Zagreb is supporting in development of the optimized operation strategy. IFAM is from Fraunhofer, helps in the development of the phase change material storage. ATT provides the IR panel heating technology. Econ constructed and realized the fiber enforced doors for the car, and Rubitam provided the PCM technology. SDS, the partner, developed the seat, and Obrist the compressor, and JRC here in Italy we are performing then also the dyno tests with the car. So the motivation of the Quiet project, I already explained. The acronym is on one hand that we are really motivated to increase the range of electric cars, and on the other hand, thermal management systems are fundamental to provide comforts to the passengers in the car. However, in the field of electric vehicles, the thermal management system can consume a significant amount of energy from the battery. And this can lead to 60% reduction of driving range in cold weather conditions, as also can see here in the graphic. But this is one major motivation. But on the next slide, we further expect, and we have further improvement potentials identified, and we have clustered this in areas. The areas are the area 1, which addresses the user-centric design, which is also a main topic in this project. And the area 2 deals also with lightweight components, which should also give a contribution to range extendment and also insulation techniques. And the area 3 are the address innovative cooling and heating techniques. So these are all areas and our focused fields of interest, which are then pursued in order to increase the efficiency, but also the user friendliness of an electric vehicle. So here is listed the development cycles we apply to all areas already mentioned. For all areas, we started with the analysis. We have here also a vehicle reference car provided by Honda, and with all areas we started with analysis. Then we developed solutions and simulation-based solutions. We developed a lot of software and we gained a lot of simulation results. We tried to increase the efficiency by the reduce of weight or the thermal inertia of systems. We have also we want also to introduce new installation techniques and new glassings for the car, and we want to integrate the advanced systems and components at the end in a demonstrator car in order to demonstrate also the range extension and also the new experience for the user in terms of HMI, human-machine interface. Here we see our reference car. This is provided by Honda. Since the Honda Fit EV is this is the Honda Fit EV is available as a study object. We have also gained at the beginning of the project a lot amount of measurement data, and this measurement data are our reference data. Will then be further used to compare with the improvements we gained with our quiet demonstrator. So we have done a lot of measurement. We have performed different real-life driving cycles, and based on that measurement data pool, we went into the development of the new quiet improvements. One starting point was also, beside of the increasement of efficiency, also to introduce a new human-machine interface based on actual user perception, which is focusing on the human, and it should be easy to use and intuitive. You can see here, this is the screenshot from the touch screen. We realized already this will be implemented in a new car, and with this the user can, by touching with his fingers, choose the for example, the upper side of the body, it's too warm and he wants to get cooled, and then this via this touch screen it will be communicated via a single board computer, as you see here. And on the single board computer we have implemented optimized operating strategy, energy optimized operating strategy, and this interacts via the CAN bus of the car with a interface box with the electronic control unit developed by AIT, and this control unit covers also safety measures, and also it controls then the valves, the pumps, and flaps from the heating and cooling system, and also with the sensors. So one very important point is to gain the energy safe, to save the energies was the development of a new and innovative heating and ventilation air conditioning system. You see here's the simulation model of this comprehensive HVAC system. We have this already built up, and we are already implemented this also in the real demonstrator vehicle. You see here the cycles. Green is for the refrigerant cycle. Here we have used a novel refrigerant cycle, propane. Propane can be used also for heat pump operation, not only for air conditioning. And this is a benefit to traditional refrigerants. And yeah, here you see the compressor. The compressor is cooling down the propane. Then it will be in the condenser, will be became fluid. Then in the expansion valve, it will then be a very cool gas, and this cool gas will then cool down here the water a circuit which the water circuit will then cool down the air in the vehicle, and then the cooling gas warms up and will be compressed again, and yes, and the circuit is closed. And with this refrigerant, it's also possible to make to reverse the direction of the fluid of the cooling gas, and then we have a heat pump operation mode. And therefore, our partners from Ventex developed expansion valve, which is an electronic safety valve, and this is able to operate in both directions. So this allows and enables also the heat pump mode. On the next slide, we see the developed special compressor for propane, developed by our partner Obris. This is the first compressor worldwide aimed for propane, and which can be used in an automotive example. And yes, and also this is aimed for propane, and since propane has the pressure is about 30% higher than compared with conventional refrigerants, this was necessary to develop this compressor. And we have already tested it at AVL Graz, and the HVAC system is working. And beside of that, I also mentioned that for our smart and innovative cooling system, we have also developed with Rubitherm and IFAM from Fraunhofer a PCM twin change material heating storage. With this heating storage, is it possible to store the loss thermal energy from the electronics? And this can be then used, for example, for conditioning the battery in cold weather conditions.
Few minutes more.
Our partners from Ecom. Yeah, how many minutes?
Few minutes, very few minutes.
Sorry. Okay, yeah. We have then here also created now the Area 3, which is the development of a effective and efficient heating and air conditioning system. Now we have Area 2. We have also developed lightweight components like this door. Here we can save about with using also with the new polycarbonate case, we can save 20% of the weight. You see here the door. The door is meanwhile finished. It consists of carbon fiber reinforced material, and is already ready. Is already finished to be implemented in a demonstrator car. We have also developed by our colleagues from LKR also a new seat structure. We have built up a completely new seat structure using aluminum and light metal components, and here we saved 15% of the weight. Then also already mentioned, we have done a lot of simulation. We have performed a lot of simulation, and here you see the simulation results in which we can say how much range we can gain with the new measurements developed in quiet. And here we see that under hot weather conditions we can achieve 10% more range. So we can achieve 150 kilometers compared to the baseline car, which is 137. And for winter, we can increase the range of about 27%. So here also a short slide. We have now we are just in the final phase of implementation of the project, but due to the COVID crisis and the shutdown, we have a delay. But at the moment, we expect the car, and also then including this lightweight glazing, will be finished in the third week of June. Then the car is complete, and then we go further on with testing, and then we can also verify the simulated tests I presented in the slide before. So I think I finished the presentation in time. This was the last slide. At that point, I would use this also to kindly invite you we have opened a special issue, our quiet consortium for the energy. We have opened a special issue, and where you can submit paper. This is the energy efficient cooling and heating system for improved passenger and thermal comfort in electric vehicles session, and it will be hosted by our professor from the University of Zagreb and Dragan Simic. They are the guest editors. Energies is full open access. Manuscripts are peer reviewed, and yes, if you are interested, please contact me by this email. Then I can give you further information, and we would be very happy if we could invite you to participate on our special issue to send your paper, your journal paper there. So thank you very much for your time and your attention.
Thank you, Mr. KAPELLER. First of all, sorry if I involved you in such an unexpected way, but the idea was to work really on cross-fertilization, so that's why I prefer to give you the floor before Mr. Boni Castagnetti. And as far as it concerns your last point, of course, we are very interested in helping you spreading the information. So if you want to share with me, you have my work email, so you can send me information or additional information, and we will try to do our best to help you in disseminating.
Thank you very much. I will do it. Thank you very much.
You're welcome. Thank you so much. Thank you for your presentation and for your time.
You're welcome.